Alright, everyone, August 25th. Alright, let's do this. I have two more. Man, what's this one? This is actually a thing I haven't done yet. Yeah, we have two more we want to redo. Alright, let's do this. Maximum length of pair chain. You are given a pair, unpairs, where this pair, each pair is left and right. Left smaller than right. A pair follows another pair if B smaller than C. Where's B? Where's C? So A smaller than B, B smaller than C, C smaller than D, then they form a chain. The length of the longest chain which can be formed. So in this 1, 2, I cannot do 2, 3 because it is equal. 3, 4. 1, 2, 3, 4. Right? Okay. 1, 2, 4, 5, 7, 8. 1, 3. Okay. So basically it's like intervals. Alright. Try to find intervals sorted. Okay. We sort by the start usually. Okay. If we sort by start, then we have some start, we have some interval, they might overlap, some, and then so we want to have this chain as long as possible, right? Therefore, I think I had done something similar before. I think it's like something greedy. Something like if you're given an interval, if the right is small, yeah, if each one we pick the right as small as possible, then we are able to get the longest. So what you're saying is if we sort the whole pairs, okay, and if the left is the same, we put the smallest right first, and each time we try to pick the one with the smallest right, and then we pick the also smallest left that can immediately follow. If we just follow this, it's like greedy, right? Can we prove it? Like if we don't pick this one, let's say we pick some value, some interval that's currently doesn't have the smallest right, and we say it has the best result. And then we can say we can always find one with the smallest left. That can also, yeah, maybe this will work. But if you want to sort this, it has to be. Now we have a question of how to sort, right? Java sort tuple. Sort tuple if first equal. But if equal, sort by the second. Yeah, something like this. Oh my god. Then compare. Comparing. Dot comparing. Dot then compare. Jesus. So basically I think I need to sort comparator lambda. I think that's something we need to learn. What if is comparing, right? Comparator to What does this one return? Comparator or comparing? What's the return value of comparator? Pairing long. This is what we want, right? I'll sort something, get a first, get a second. So I think if this is smaller than 0, okay, so we probably can do that. Yeah, it should not overflow. Yeah, I need to know how to sort them. How to sort this. Ugh. Alright, so we have to say arrays.sort pairs, right? And then we can say p1, p2. P1 0 if it's equal to p2 0. Okay, if it's equal to, then we shall return p1 1 minus p2 1, thus p1 0 minus p2 0. And that makes sense, right? If they're equal, if the first one is equal, then we compare the second one, the smallest to go first. Otherwise, we say if P1 and the 0 is not the same, then the smallest, that P1 goes first. I mean, we can run a little, right? Console, not console. Pairs dot to string, okay? I want to make sure that this one's correct. Oh, we can create something, right? We can say 10, 11, 10, 21, 1, 2. Perfect. Perfect test case. That's not what it's supposed to be. How to print. Yeah, and I guess we cannot do that. I forgot how to print a 2D array. Oh, arrays.deep to string. Gotcha. Pairs. Yep, I think that's correct. Okay. So now I sort this, right? And now we can say res equal to 0 because what we want to find out is the length. And then we can say for each one, when the start is so int pre-write is equal to, I don't know, minus integer dot maximum. Oh, maybe I should do integer dot min value. Yeah, dot min. Wait, what is integer dot min value? Minus this. Okay, so that's the pre-write. Okay, now we can say for int this tuple of pairs. We can say if tuple 1 is larger than pre-write, res plus plus pre-write equals tuple 1. Okay, if it's smaller, then we just keep going, and at the end we're gonna return pre-write. Yeah, I'm not sure. That one, this feels a little bit too, how should I call it? Too easy. Yep. Huh. How come it's 4? How come it's 8? Oh, I return pre-write. That's not right. I should return res. Why'd you return pre-write? Alright, still not right. Oh, my bad. 0. It's a 0 larger than. Okay. Let's go with this. Nope. Doesn't work. Output 1, expected 3. Alright, let's take a look. How this one look like. This. And everybody. Okay. And then the last one. Alright, let's first make sure system.out.println pairs arrays.deep to string pairs -9 8 -6 -6 -5 -4. Okay, so at least I have 1. Oh, now I have 8. Oh, that ain't right. Ah, I see. So, okay, so this method doesn't work. So now what? Now we probably have to DP this. So we still sort. I think we still have to sort, right? Then we can say if I include some, right? If I include some, yeah, greedy doesn't work. If I include, let's say, starting from the current, what is the longest? Okay, starting from the current, whatever this current is, what we want to find out the longest. Starting with the current. we want to find out the longest. Or we can say from this position to the end, what is the longest? Then we need to start from the front, right? 0 to the end. Then you can say we either include it or we don't include it, right? There are two ways. So if we include it, then you have to find something that's, much down the way. If you don't include it, then you go for the next one. So with that, then you can say it's gonna be like a DP problem, right? We have a memo, which is record DPI. Then how do we find? Now we can probably just search, or we can binary search, right? We can binary search, but I think the total length is only 1000, so I probably don't want the binary search. I'm probably can just straightforward search. Binary search might not even give you a fast, but we should actually binary search. How do you binary search? Well, you have a left, have a right? So you need to find a left, the biggest, then the smallest left that's bigger than this. So if I have all the left, if you write it out, all the left, then you can binary search to put this one in, the first one, right? The first one. Yeah, I guess we can binary search. Okay, how do we do binary search? No, I want to know how binary search can be done in Java. What's the built-in? Yep, this one. Erase the binary search. Key. Minus insertion point -1. The index of the first element in the range greater than key. Return -1. Basically, we need to minus -1. So +1, and then in reverse. +1 in reverse, 12. +1 in reverse, 6. 0, 1, 2, 3, 4, 5. 6 is the position. Okay. So So yeah, we can binary search. Binary, can we use like a key or something like that? Can we pass like which one we can do? Can we say hold on, arrays dot binary search? Yeah, we can do a comparator. But probably that's not. I don't know. What would be the best way to DP memo? Okay. At different positions, right? Yeah, we sort it, and then we need to binary search to know which one to start. Can we can we do a binary search? We can actually try. So this is not gonna work, which is fine. Can we try, let's say, arrays.binary search pairs. Okay. Key. That doesn't matter. We can do whatever key we want. Let's say probably should system.out.println arrays.deep. I need to print this out. We will do, let's do 5. Okay, 5 sounds a good idea. Key is 5, and if we do this directly, it's not gonna work because it's not what we need. What if we do a comparator? Or nah, that's what if we do this, right? And yeah, that's fine because it's equal. We want something that's it's smaller, right? It'll be the first one that's bigger than this. That's so. What if we find something that's equal? If we find something that's equal, then we shouldn't. So we need to find something bigger, which is fine. I think it's fine. So I can do, like, say, integer dot max value. Can we do that? New int. We just create this. Is this possible? Okay, let's return this. Okay, let's try it. What's the return value? Maybe we need a comparator. -8. Okay. I agree, we can use that. -8. -8 plus 1 -7. So the input is 7. 0, 1, 2, 3, 4, 5, 6, 7. That's the first one that's bigger. I think it's working, right? This is working. Okay, so with this, I think we can start. Okay. Then we need to say private int dp int index. So from this to the end, what is, so we just say if index okay. I just return 0, right? Because if it's outside the DP, it can make 0. Then if memo index is not equal to null, of course we return memo index. Otherwise, so when I say from index moving on, actually I can do pairs, sorted pairs, right? Sorted pairs. So actually do this, we can say this dot right. Oh, okay, we go. Sorted pairs no length. Alright. So from this to the end, I can always say either we can say memo index can equal to I don't take, then just dp index plus 1. Okay, so not taking sorted pairs index, we just don't take it. Okay, we skip it. We try the next one. Otherwise, then we say int binary bin index shall equal to race dot. I'll put this one here. Alright, race sort the pairs, new int. This is going to be sorted pairs index, right? 1. So this will give me a binary index plus 1. Then we take a negative of the entire thing. So this will give me the actual index, who is larger than this, right? Then what we're going to do is say memo index shall equal to math.max memo index and 1, because I take current one, plus dp binary index, right? Binary index, we'll just do that. Once we're done, we return memo index. So that's the dp part. So once we've done this, then we simply can return dp 0, because we all start from 0. And if we run this, it'll give me an error because something is out of range. Which part? Oh, it can find. Ugh. What it finds? Then, ooh, that's actually a good question. What if it find? What if I have a multiple? Which one do you find? Multiple matches, exactly. So basically I just want bisect right. Java bisect right. Do we have bisect right? There's no guarantee which one will be found. Oh my goodness. I guess it's fine. Because I think I shall pre-treat the intervals. If you have the interval that have the same value, right, then you shall only include the ones with the minimum. Well, I think that does make sense, right? You should only include the one that has the minimum, which means you might as well just go through the whole thing, probably using a map, like a hash map. So you keep the smallest, right? Then you sort the left. You sort the left, and then you go the left. Because you have the same start, you cannot all use the same start, right? That does make sense. If you have the same start, I'd rather use a one with a shorter left, shorter right. So there is a little bit. So yeah, I'm gonna make some changes. Memo is still right? Just when you do this, and but if you have multiple, yeah. So we don't have to do this. So memo is fine. We're going to do a hash map of integer, right? A pairs. Left, right. So left, right, the new hash map. Okay. And for int tuple of pairs, you can say beautiful. Hash map. So left, right, dot compute if absent. Yeah, let's just do if left, right dot contains key tup. If it does not contain a key, then left, right dot put tup 0 tup 1, right? That's if. Else if it has, then left or right dot put tup 0, and then math dot minimum. We want a minimum. Tup 1 and left right dot get. Oh, I can say get default, right? Get or default tup 0, or we want a minimum, so math integer dot max value. So I think this one is enough. This one's enough. Right, which is always put. So at the beginning, it's default, which is largest. So we put this. No, so we do this. All right, then we say int lefts equals to new int. No, I think we can do left right dot key set dot to array. Does this one work? To array integer. No, how do we do to array? Key set to array. Key set to array. To array new int. So what's the size? Can I do 0? No. Right, left, right dot size. No. It doesn't make any sense. It doesn't work. Oh, it has to be this integer. And then new integer. Left, right dot size. So what do I do this? We do this 0 size. Okay, so we have lefts. Can I do raise dot sort lefts? That's fine. So we sort this. Self dot sorted. I can say. Okay, so we can say hash map left. No, integer left right. Integer lefts, and then this dot this dot this dot. Okay, this dot this dot. I guess we don't need to this dot because there's only one. Yeah, I think it works because that's the only one. There's no confusion. So left equal to this, then we sort it, right? And then we do DP again. Then you want to call it sorted lefts. Yeah, probably should call it sorted lefts, right? So all here are gonna be sorted lefts, right? And then blah blah. Yeah, we'll just skip it. Otherwise, we'll do sorted lefts, and we'll get it first binary. So by sorted lefts, and we have to change this entire thing. That's just gonna be left right dot get sorted lefts index, right? Then we say if binary index is larger or equal to 0, which means we found it, then we need to find the one that's bigger than it, right? Because that's the right. We're gonna find a left that's bigger than that. So bin index plus plus. Else, if it's smaller than bin index, shall equal to minus bin index plus 1. Then this shall equal to maximum this or this, and now we'll return this. Okay, with this, what do we get? It'll be 3. We get a 3. I'm not sure. I forgot the answer to this question. Let's try this. We have a wrong answer. Yes. Oh, it is 3. Okay. Does this one work? It does, but it's quite slow. It's quite slow. 646. First, remove all duplicated, condense all the pairs with the same start and condense to one pair whose right is the smallest. There is a bit greedy to play here because for multiple pairs with the same start, only the one with the smallest right can offer the best chance of forming a longer chain. Then we use DP to find the answer, where DP index. Then we sort the lefts in the remaining pairs. Turns the max chain length of left's index towards the end. So, not sure, but we use a binary search here. So it's log n, and we have index, right? But each one, you go 2 options, right? So, but didn't you go through? Yeah, I mean, there's only this on here, right? This is o1 log n, this o1 log n, and then when you call dp, we only have n states, and each one you only did two times. So I think it's O1 log n. But why is it so slow if it's O1 log n? You did split 2, right? You do this, and then you did this. You basically call it 2 times. But you call it 2 times, but there are only that many states. So yeah, that shall be 2n, right? So you don't have to keep computing them, because you compute each one only once. And there's a log n, so is that just O and log n? I'm not sure. If it's O and log n, why is it so slow? How many test cases are we talking about? Only 200 or so test cases. Is that not O and log n? Ugh. That was so easy. I think this is O and log n, right? This is O1, this is O1 login, and this end states, and even though each time we do 2, yeah, but only end states. It is O1 login, but it kind of slow. Yeah, because we did DP for this, of course it's going to be slow. I saw the right solution. Oh, I was worried that we made a mistake. It's actually no. I just want to copy and paste this. I think last time we did better. I think what I saw is you sort based on the tail. If you sort based on the tail, and then what? You sort based on the tail, and I don't know. What was the previous method? Well, I did have more test case than before. I sorted based on tails. I think this is the greedy approach. Oh, I sort based on tail, and then I start to go from front to back. Huh. You sort based on tail, then go front to back. Sort based on tail. Smallest the tail goes up. So you're trying to say that we want each tail to be the smallest, okay? And then you start. So it is greedy. It is greedy, but just with a different touch. So if we take a look, if we borrow this, right, we're still greedy it, but just slightly different. So we sort based on tail. So if the tail is, no, hold on. If the tail, so yeah, if the tail is the same, then we do the front. The smaller front wins. Yeah, the smaller, actually really, the smaller front wins or the bigger front wins. So if the tail is the same, it doesn't really matter, right? Because it doesn't really matter actually. Because as we go, if the front stick too much, then it won't, yeah, it doesn't really matter. So I think I can just, I think I can return compare int tuple. I just compare tuple 1. This is all fine, and then we just do the same thing, and it will work. So this is the solution from the last time I did the problem. More than, I don't know, more than a year ago, right? Back in March 2022. We sort on right, then greedy it from left to right. Since each time the right we encounter is always the smallest so far, so we are guaranteed to always be at the optimal position for extending the chain. Thus, the greedy works. Earlier for me, I sort based on the front, and yeah, that of course doesn't work because the end can be anywhere. But if we sort based on end, then each time the one you choose is the best so far that you can get. And this is of course O1 log n. Okay? And performance will be very good. 2 seconds. Well, actually, it's not. So the DP is not too bad. Okay? DP is not too bad. It's encouraging. Where is it? Alright, let's see. What are the solutions? Recursive DP. Oh, squared. Iterative DP. Pairs I1 is smaller than, then DPI equal to maximum, DPI and a 1 plus. Yes. Greedy. Yeah, DP can work. It can make it a little bit better. Okay, that'll be it. Let's just end it right here. Alright, I'll see you guys tomorrow.